Welcome back everyone to Teach It a series on FluidSIM. Last week we covered time delay valve and we showed you what is basically a time delay valve, how it functions, what are the main components of a time delay valve, and also we looked at one industrial example and we basically designed the pneumatic circuit inside FluidSIM for that specific application. In this video, we are going to focus on quick exhaust valve. First, we'll show you what is a quick exhaust valve. We'll discuss the functionality of quick exhaust valve and the main components of a quick exhaust valve. And then we'll look at one example, an industrial application, and we'll show you how we can design this system, basically the pneumatic circuit of this application inside FluidSIM. Without further ado, let's focus on what we have for quick exhaust valve in terms of functionality and its structure. So, quick exhaust valve basically used for exhausting of air, and in general it has been designed especially for pneumatic systems. So we will see basically quick exhaust valve for exhausting air in pneumatic system. So one important thing is during the extension and retraction of the cylinder, compressed air is supplied basically to one end and the air is present in the other side of the atmosphere, and that air is basically exhausted to the atmosphere. And also we know in general it is a long path for the air to travel through pipes to be exhausted with the exhaust port of the directional valve. So if the air is coming out from the exhaust valve, it is going to take a few seconds, depending on how much is the length of the pipes, even minute, to get the air to directional control valve and exhausting it to the air, right? So in order to avoid this lengthy process, quick exhaust valve is used, and we generally use it at the cylinder port. So we have double acting cylinder or single acting cylinder, and we add it to the ports of that cylinder depending on if you want to use it in the pressure port or the exhaust port. We use it there in order to have a very quick exhaust of the air. So from there we can say quick exhaust valve is basically used to exhaust air to atmosphere at cylinder outlet port, and that is helping us to avoid lengthy travel of air inside the pipes. And if we want to look at the structure of quick exhaust valve, let me bring this pointer here. So as you can see, we have basically three different ports here, right? And we have a rubber seal inside, right? And as you can see, we have inlet port, we have cylinder port, and we have exhaust port basically. When air is coming from the cylinder port, pressure port is going to be blocked. Let's say air is coming from this side, pressure port is going to be blocked, and the air passes to the exhaust port from this side. And then basically the air is coming from the compressor. We are supplying the air from the compressor. Basically the air will push this rubber towards the exhaust. So the exhaust side, the exhaust inlet is going to be blocked and the air will pass through this line. Okay, so that is how in general a quick exhaust valve functions. So what we can say in summary, quick exhaust valves are used to increase the piston speed of cylinder. Depending on if you are in retraction or advancing process, if we add this quick exhaust valve on either of the ports that we have, for example for double acting cylinder, we can increase the speed of advancing or we can increase the speed of retraction depending on where we are adding that quick exhaust valve. And basically this enables lengthy return to be avoided. So we would have a very quick retraction, or we would have a very fast advancing. And the principle of operation is basically in general is to allow the cylinder to retract at its near maximum speed by reducing the resistance, because if you're adding the quick exhaust valve at the ports of the double acting cylinder, we are reducing a lot of resistance, because that air should pass through lots of lines to get to that directional control valve which has the exhaust needed for exhausting the air to the atmosphere. And to reduce the resistance, the air is expelled to the atmosphere close to the cylinder using basically the quick exhaust valve, as you can see in here. I already explained the structure. What we have in general inside FluidSIM or inside any pneumatic circuit for basically quick exhaust valve in terms of symbol, you can see the symbol in here, and we have the three different ports as expected. So this is going to be that rubber seal, or let's say a ball, and that is basically justifying the air to be passed to the inlet, basically to the pressure port or the exhaust, depending on where we are basically putting this quick exhaust valve. Here we can see one example, one simple example of quick exhaust valve, right? So what we have in here, basically, as you can see in the retraction process, basically on the other side, we have this quick exhaust valve, which means when the system is, this double acting cylinder is, this single acting cylinder is exhausting, we would have a very quick exhaust because of the use of this component in there. If I push this button, right, the air will be passed, right, and this ball moves to there. This is going to have the air, right, but when we have the exhausting, the air come here, right, first it pushes this ball to this edge, the air cannot pass, therefore it should exhaust through the port number 3 to the atmosphere, right? And here what we have the quick exhaust valve on advancing procedure, which means if the air is coming to the system, right, we would have again the same functionality in there in terms of a speed of motion that we expect for this piston, right? So in general, as I said, the application of quick exhaust valve is to increase the speed of advancing or retraction, and it depends on where we are using that quick exhaust valve, on which port we are using basically that quick exhaust valve. And if you want to see where we use quick exhaust valve and what is the main application of quick exhaust valve, let's say if you want to punch something, right? Basically in industry, when we are dealing with punching, we need to have a very fast advancing for the basically the double acting cylinder or single acting cylinder, and that is where for double acting cylinder specifically we need to use the quick exhaust valve in order to have a very fast motion, the maximum motion possible for that double acting cylinder. Okay, now we have a bit of background on what is quick exhaust valve, how it looks in terms of symbol, and what we have inside quick exhaust valve, how many ports the quick exhaust valve has. It's time to look at one example, and then once we cover the circuit of that basically example, we'll go to FluidSIM and we'll show you guys how we can design this circuit with the use of FluidSIM. Okay, the example says we have the combined actuation of a manually actuated valve and a roulette level valve, and with this combination basically we can advance a forming tool on edge folding device. The forming tool is driven by a double acting cylinder. So there are a few important information in the first sentence. As you can see, we have combined actuation of two valves, which means we need to use a sort of AND logic. If that AND logic is met, basically we would have the next step of the process, right? Therefore, in the system we need to use a twin pressure valve. and it says the forming tool is driven by a double acting cylinder, which means we need to use a double acting cylinder. Easy, this part is very easy. And then for rapid forward travel, which means we want to have a very fast advancing, the circuit utilizes a quick exhaust valve. This is where we need to use a quick exhaust valve because we want to travel with the max speed possible, right? And the retracting speed, this is another important information. The retracting speed is to be adjustable. And finally, it says if either of the two valves are released, the tool returns to its initial position. So we have to use quick exhaust valve as the problem says, and it says the retracting speed is to be adjustable, which means we need to use a sort of throttle check valve, right? Because with the use of throttle check valve and changing the opening level of the throttle check valve, basically we can change the speed of retraction, and if the problem asks for the advancing, that is going to be added to. But here for advancing process, we are looking for a very fast motion, right? And for retraction, we just need the capability of adjusting. We want to be able to adjust the speed of retraction. So I extracted this example from Festo Pneumatic Basics, the textbook. And as you can see in here, I already put the circuit, and for the first part of the problem, it is saying a combinational basically actuation, right? And it says we have push button or manual actuation, as you can see in here, and we have a roller level valve. And roller level valve is basically linked to the position of the piston, and as you see, we have the same thing, and we have that basically identification that is showing us, okay, the system, basically the piston is in fully retracted position, therefore it is ready, right? This is sending a signal to the twin pressure valve. Whenever we push this button, the system starts operating, right? Now it is basically that combination, and that condition is met. Once we have the air pass through this line, this twin pressure valve, because both conditions are true, it passes the air here. This pneumatic actuation will be basically actuating and shifting this directional control valve to its second position. Air will pass through this arrow, right, and it gets in here, and then we are in the throttle check valve. The throttle check valve has two passes. You know, we already discussed how the throttle check valve works. First, it looks this side, right, and it says it is basically a free path. The air, notice it has a free path, so it decides to move through this way, and then it gets inside this double acting cylinder. The pressure results in the force needed for moving this basically piston towards fully advanced position. Because we have this quick exhaust valve here, right, the air is passing through this line and it gets here, right, and when it gets here, coming from this side and pushing this ball towards the edge, right, and it cannot pass through this line, therefore it exhausts quickly from this way, right? So that is how a quick exhaust valve functions and helps us to have a very fast motion. And once it reaches to 1s2, because of that quick exhaust valve, we would have a very fast advancing, and then once it reaches to that point, it quickly returns back. And because we have this throttle valve, again the air comes here, it can go basically from this side first, right, or this way. First it checks this side, and this ball basically blocking the path of the air, therefore the air should pass from this way, right? Depending on how much opening that we have for this throttle over there, the air can pass and the speed can be controlled, the speed of the throttle, the speed of the piston. Okay, so that is how with the use of quick exhaust valve and throttle check valve, we can control the speed of piston and the speed of piston inside a double acting cylinder. In the next part of this video, I'm going to show you how we can design this circuit inside FluidSIM and we'll discuss how basically we'll see how fast a pneumatic system can work when we add a quick exhaust valve to it. Okay, in the first part of the video we saw how basically a quick exhaust valve functions, and we also looked at one example and we saw the circuit related to that example. And in this part of the video I'm going to design that circuit inside FluidSIM. Without further ado, let's start designing the circuit inside FluidSIM. So what we had in there, we had a double acting cylinder, right? And we had a basically throttle check valve. So throttle check valve. So I'm going to rotate it 180 degrees and then connect it here. And the other thing that we had was a quick exhaust valve. So for a quick exhaust valve, you can see it's here, just connecting this part here, right? And we need to have a directional control valve which is configurable with 5 ports and 2 positions. So I'm going to add this here, and that is going to be connected to the port 2 here, as you can see. And the other thing that we need to have is connecting port 4 to this one here, right? So that is done. We have to basically configure this one. It is going to be pneumatic actuation from the left side, a spring return. And then we need to bring a twin pressure valve, because as you might remember, we had a combinational valve, right? We need to have a combination of actuation in order to system start operation, right? So what we are going to do is bringing a twin pressure valve from flow control valves. So this is the twin pressure valve, and the outlet port should be connected to this pneumatic actuation of this directional control valve. And then we need to bring 2 configurable valve with 3 ways, 2 positions, as you can see. So I'm bringing the next one, and this is going to be connected here. This is going to be connected here, right? And we need to bring the supply elements too. So before doing that, I'm just going to configure this valve. This is going to be manual actuation, spring return, and this is going to be roller lever valve, mechanical form of actuation. At the end, it's going to be linked to the position of the piston in there, and a spring return. Hit OK. And we need to bring the supply elements. So the supply element, compressed air supply, as you can see here, and this one too, right? And the exhaust should be there, and the same thing this side. And I'm going to bring another supply element here and 2 exhausts. Another one should be here. Okay, now we have everything set in terms of components. We need to just basically add naming. This is going to be 1S1, this is going to be 1S2, right? Labels, and this one is going to be called 1V1, right? And here I'm going to call it 1V2, 1V3, and this is going to be 1V4, the quick exhaust valve, and we are going to call this one 1A. And as the problem is saying, the speed should be adjustable for returning, I'm just going to change the opening level of this at the end. Okay, we'll see how it is affecting the speed of retraction. Now there is one part left. We have to link this basically roller valve to the initial position of this double acting cylinder. So this is actuating labels. This is going to be called 1A, and we would have 0 here at the initial position. It is linked. Sorry, this is 1S2, the directional control valve 1 S2 is linked, and hit OK. See, that is now in the initial position. It is linked. As you can see, the symbol is representing that. Right now we have everything set. It's time to start the simulation, see how it works, and if it is not working, if there is any like bug there, we can basically easily debug it after looking at the functionality of the system. Okay, let's start. And now if we basically push this button, you see everything is going to be very quick. The system returns back to its initial position very quickly, right? Because we have a quick exhaust valve which is helping us for that return scenario, right? And to have that advancing scenario with a very fast speed, and also the retraction too. And if we change the opening level here a bit, let's make it 5, and now if we push this, you see it is taking a bit to return back to its initial position. You see, so with that, with the use of throttle check valve, we are adjusting the speed of the retraction, as you can see in here. So that is how we basically use quick exhaust valve inside pneumatic circuit, and how it basically functions within pneumatic circuit. Thank you very much for watching this video. Hope you enjoyed and learned how quick exhaust valve working and how basically they work inside pneumatic system. If you enjoyed and learned how this component works inside pneumatic circuit, please subscribe our channel.